Welcome back. In this session, we'll discuss about variables and data types. Dear friends, we executed this program to show the basic operations between two constants. Suppose if I want to change the two constants, every occurrence of the first constant has to be replaced with the new constant, and every occurrence of the second constant has to be replaced with the new constant. Again, if I want to change to another constant, again I have to write this with new constants. So it is tedious work. Instead of that, if you can use variables, say AB, where A contain the value 5 and B contain the value 2, instead of writing 5 plus 2, you can write A plus B, A minus B, A into B. That is, in terms of AB, you can write all the operations. Now, if you want to change the value, you just need to change here. The rest of the story, we don't have to change. So that is the advantage of variables, my dear friends. Okay. In C language, these variables are the abstractions for the memory cell. That is, every variable is associated with a memory depending on the type of the variable. Okay, some variable may have 1 byte, some variable may have 2 bytes of memory, some variables may have 4 bytes of memory. That is, the variable is associated with that particular memory cell. So the memory cell can be called with the name of the variable. And before using the variable, you must declare the variable for the benefit of comparison. Before using it, you have to declare it. That is, here you cannot write A is equal to 10 like that, sir. You have to say what is the type of the variable. So you have to mention what type of the variable and what is the name of the variable. This is called type of the variable. It is called name of the variable. Then you can use it. Similarly for B also, int B, you can write the variable, type, name, then you can use it. So this is the syntax for variable declaration, my dear friends. See, in C language, the declaration and definition of the variables are same, okay, except for the external variable. Remaining all declarations and definitions are same. So when you declare it, automatically the memory will be associated, my dear friends. Okay, so here it is considered as both declaration as well as definition, my dear friends. Okay, data type and variable name. It is like int, you can write some name. See, I'm just using short names. You can use some good names also. Suppose if it is representing some selling price, you can write selling price. You have different practices for that, you can use it. Or SP you can write like. So you can write the type and name. This is called identifier. You already know what are the identifier and rules for identifier. Using a proper identifier name, you can name the variable, my dear friends. Now, variable will have these 6 attributes associated with it. So once you declare a variable, these are all the 6 attributes associated with the variable. The first one is name. Of course, you only give this particular attribute, you name the variable. And of course, you will tell what is the type of the variable, like int, char, float. These two are given by you. Then the other attributes it will get is address, because every variable is, okay, abstraction for the memory cell. So that entire memory cell address is given to the variable. See, for example, I have integer variable, which is, say, occupying 4 bytes of memory. Okay, suppose it is starting, say, from 4000. 4 bytes means 1 byte address. Each memory will be having some address, my dear friends. Okay, so first byte address is, say, 4000, second byte address is, say, 4001, third byte address is, say, 4002, next byte address is, say, 4003. Then what will be the address of this variable, sir? See, the address of the first memory location is the address of the variable. See, even though the integer takes all the 4 bytes, all the 4 bytes are allocated to the integer or the variable, okay, integer variable. The first memory location address is address of the variable, and the address of the variable we call it as L value. Address of the variable is what is known as L value. Then comes value. That is, what is the value you store in that particular location. That is called R value. Okay. R value is value stored at that particular location. L value is address. R value is value which you store at that particular location. See, generally, the local variables, if you don't assign any values, garbage values will be there, sir. So you have, of course, there are some rules. We'll discuss all that. So you have to know what is the value you are storing at that. If you don't store, sometimes it may store 0 depending on the type of the variable, or some variables may have some garbage values. Okay. So that is the value which is stored at that particular location is called value of the variable, or we call it as, technical term is R value. Then life. Life means time during which that variable is associated with that particular memory cell, how long the variable lives. Then comes scope. See, even though some variable may live throughout the entire program, but they can be accessible only within some parts of the program or within some blocks. That is what you mean by scope. The range of statements over which the visibility of the variable is available. Okay. So these are the attributes associated with every variable, my dear friends. So if I define 3 variables here, it's a simple program where I define 3 variables. Character, the name of the character variable is ch. Integer variable, int is the type, a is the name of the variable. So for every variable, memory is allocated depending on the type of the variable. See, each type will have some memory allocation. For example, character is having 1 byte. Integer, in some old compiler it is 2 bytes, but in new compilers it is 4 bytes. So in my compiler it is 4 bytes. So 4 bytes of memory is allocated. For example, it may be allocated a memory, say 4000. Then the integer may be allocated the address 4004. 4004 means 4004, 4005, 4006, 4007, but the first memory location address is address of the variable. Then float is again 4 bytes. Okay. So float also, of course, it's not int, sir. The name of the variable, it should be name of the variable. Name of the variable is okay. A. Name of the variable. Okay. 4004. Then here F. Suppose it is taking 4008 onwards, 4 bytes, 4008, 4009, 4010, 4011, but the address of the variable f is 4008 only. So once you declare the variable, memory is allocated to that particular variable. Am I clear? So every variable will have a name. Name is given by you. Type is decided when it is created. Okay. Then L value, the address. Address is allocated directly by the operating system or the compiler. Okay. And the value, if you don't give garbage value, if you give that whatever value you send, that will be there. Then the life and scope will be discussed later on under storage classes, my dear friends. Now, as I told you, for every type, when you write int a, this is the data type. Type means what type? Data type. Integer data type. This a is the name, identifier. What is it? It is identifier. Then address. Address is L value. See, I just given 4000 means don't always take for every variable 4000 is the address. Just I am directly giving some dummy value, sir. If you want to know the address, you can write scanf function and you can say ampersand a, you know the address of the variable. We'll see that. Okay. Then the value. See, initially if you don't assign anything, it may be garbage value, but once you make some initialization, that 10 value is stored in this particular location. Remember, L value means address, R value means value at that particular address. Now let us see a simple program where I declare variables, I assign values and I print them. Okay. So as usual, we start with hash include stdio.h. Then this is my main block. Okay, main block. So I just define 3 variables and I assign some values to them. Then I print the values. See, there are different ways. Of course, if there are different types, you have to define them separately. If you are having three of same type, you can define together. Okay. So here I want character variable ch, integer variable, okay, iv, and float variables fv. Okay. You can character variable also, let us use the same nomenclature like c. So we declared three variables. You can assign the values. Character, see, character constants you can assign, or you can also assign the ASCII values, sir. Both are fine. Okay. You can assign the character single quote, the character you can assign any character, sir. Okay. Let us say S. My name starts with S, so let us use that. Then integer variable iv. Okay, it is character variable. Don't use different names. You have to follow the same, okay, names, identifiers. Integer variable, you can assign some value, say 190. Then float variable, you can assign some value, say 19.45. See, if you want this initialization, you can do here itself. For example, this particular portion, instead of doing it here, you can do here itself. You can do this here itself, or separately also can be done. You can do here itself for each of this integer, float also you can do initialization directly here, or separately can be done. Now what we do, we try to print the values. We try to print the values. Okay. So I want to print the values. Okay. And if you want, you can also print the addresses also. Okay. So for addresses, you have to use ampersand. Okay. Let us see addresses. Addresses of, okay, or addresses of, or all of them at once. Address of CV, character variable, is percentile. Of course, you can use percentile P also. For addresses, we use percentile P. Percentile D also will give you the address, no problem. In integer format, it will give you. Okay. So similarly, you can write address of other variables, but you have to send that address means ampersand, sir. You have to write ampersand CV, give you address of the variable. CV is the value, ampersand CV is L value, address. CV is the value, semicolon. So you can do the same thing for all other fellows also. So here you want integer variable, here you want float variable. So you send IV and you send float variables. And you can print the values of the variables also. And please remember, if you don't keep any \n, they all be printed together. Okay, so let us use \n so that they all will be printed in the different lines. Okay. Now I want the values of the variables which are initialized. So you can just write down character variable is equal to, you are sending that particular value, \t. Integer variable is equal to percentile d. See, character, if you want to print as a character, you can give percentile c, because for character variable, the conversion specification is percentile c. C is the specifier. For integer variable, percentile d, and for float variable, it is percentile f. Okay. So you have to send them, and please use this \t so that they will be printed in a well formatted manner. So the character variable, integer variable, float variable. Please check for any errors. Otherwise, you can run the program and verify. Okay. Let us run the program and check the answer. So you can see the addresses of each and every variable. It is stored at 303 address. It is stored at 296 address. Okay. Now it is stored at 292 address. 292. Okay. So it is going from, like, lower address to higher address you are going. Okay. That is how it is stored, my dear friends. So these are the values. You can see CV, percentile C, you got the value S, and integer value is 190. Float, see, float will not be stored exactly, my dear friends. So don't expect what you write exactly that will be stored, okay, because precision also will take care, considered into account. So that's why we never compare two float values. So it will not be stored exactly how you stored 0.000 like that, okay. So some additional values may happen. That's why we generally don't compare floats for equality, my dear friends, okay, remember that. So that is the program. Now let us understand what data type determines. My dear friends, when you declare or define a variable like int a is equal to 10, this will tell you the type of the data, okay. And once you know the type, for each type there is different allocation of the memory. So we also know the size of memory allocated to that particular type, the range of the data. Once you know the size, you know the range. For example, size is 1 byte means 8 bits. 1 byte means it is 8 bits of memory. 8 bits means you can allocate 2 power 8, that is 258, okay, numbers can be stored in that particular one. So suppose you are going from 0 to positive, then 0 to 255 numbers can be stored. If you are going from negative to positive, you can store from minus 128 to plus 127 numbers can be stored with that particular 8 bits. So that is the idea. It tells you the range of the data. And one very important thing is, now suppose I defined three variables, A is 10 initialized, B is 15 and C. Now I can do C is equal to A plus B. My dear friends, when you say a variable is defined, not only its size, range and type are described, also the operation, because these are all the default types defined in the C language. For default data types, not only the type, size, range, even the operations are also predefined, built in. So because of that I can use it. See, even this is assignment. Assignment is also predefined. Because of that you are able to assign. You can do addition, you can do subtraction, whatever operations defined or possible on that particular type, all those operations you can directly perform because they are all predefined, built-in features given by the programming language. So when you say data type, don't just think that a variable. Data type means a variable which is having a type. Type determines the size, size determines the range, and because of the type, what all operations can be performed, you all know that. That is, all the operations are all predefined together with the data type. That is the point to be noted. Now in C language, we are having different data types. We can classify them as basic or fundamental data types, derived data types, okay, then the user defined data types. See, the fundamental data types are the character, integer, float, double. Void we'll discuss mainly with pointers, okay, and with the written types of functions and other things, my dear friends, but basically we discuss these four data types here. Then derived data types are, see, these are like group of things, okay, maybe similar or different things, okay, or a special type of data types which can be used for different purposes. Under that we have arrays, pointers and strings. These are, of course, string is also as array, is a kind of array only. Pointer is a special type of data type which is used to store the addresses of the variable. Okay, they are all derived data types, not built in. I mean, they are all available in the language only, but they are not fundamental. They are called derived data types. The other one is the user defined data types. See, these are the constructs which are provided by the C language to create your own data types, like struct, union, typedef and enum. Struct and union are mainly used. Your typedef and enum are special purposes we'll discuss when we talk about the user defined data types. And these data types, fundamental data types, comes together with modifiers या तो qualifiers. See, modifiers are either size या तो sign modifiers. So they can change the size of the type or the sign of the type, whereas the other one is called qualifiers. In this, we mainly discuss constant only. Volatile is beyond the scope of this particular C programming, which we are going to discuss, my dear friends. Constants, once you mention that constant keyword for any variable, okay, or a function, the value cannot be changed. Its value cannot be modified. That is what constant qualifier. Okay, so it gives the special properties to the variable, yeah, the function for which it is associated with. Okay, so once you associate the constant qualifier or volatile qualifier, that they give you special properties to the variable, yeah, to function to which they are associated with. Constant tells you that its value cannot be modified. What about volatile? Okay, see, if anyone asks, just remember, you don't have to know anything more than this, my dear friend. The volatile keyword specifies that the value of the object can be changed by something other than this particular program. Okay, generally it is used for the objects that are accessed by the hardware devices or other processes. For such fellows, we are going to assign this volatile. Am I clear? They are changed by the other processor or generally hardware devices for which it is connected. Am I clear? So that is the purpose of volatile, my dear friends. So it is beyond the scope of our syllabus. So we are not going to discuss volatile anywhere. Okay, remember. Now the basic data types. Let us discuss these basic data types in detail in the next video.